All right, so here I am at 9:15 p.m. with one client, the only client that can get me to work at 9:15 p.m. It's Will. And I have Ray, the contractor, framer, and amazing dude too. Because if it was with Will, he must be nice. All right, so what do we have here? So we have a condition in which we're trying to open up this baby right here, right? That baby.
Yes.
So we're all in agreement that we're gonna try to open up that baby. And that baby spans a length of 16'6". Sorry, it's backwards, but 16'6". Okay, so that's the span. And our joists are sitting right on it like this. We know that because there's a portion of that ceiling that's open so we could see it. So that was great. So there we're sitting right here. There is another reason why I know they're spanning that way is because this will be way too long for them to go. And that wall is a structural wall, even though it's a tiny little weak wall that we looked and it's like not even 2x4s, it's like 1x4, but sitting right there. Okay, so we got that condition. The concept number one that I want, which you probably all understand, is that LVLs typically are sized by how long they're spanning. So if something's spanning, let's say 10 feet, they are typically going to be that same depth, but in inches. And that's just an example because there's not a 10-inch LVL that I know of. They're typically, that's not the size, but they're going to be in inches. So if we have a 16'6", 16'6" span right now, what would that be on LVL sizes?
16'6".
Yep, about 16 inches in depth, something like that. You got it. 16 inches in depth. So depth, we're talking about an LVL is something like that, like that.
No, would that just be one LVL or would that be two 16-inch LVLs?
Good question. We're gonna get to it in a sec. So we get this guy right here that's gonna need to be 16 inches, and LVLs are represented with different layers like that, right? So I'm not even talking about the length because the length is obvious. It's gonna have to be 16'6" in length, but in feet, but it's gonna need to be 16 inches in depth. Great. Now that we understand this little baby concept of this condition, we can go to our number one friend, or structural software. Yeah, I don't do the math. I use the software. So yeah, sorry to burst your bubble. But we go here and the structural software shows us span length is the number one thing I want to know. It's gonna be 16 foot 0.5 feet equals 6 inches. It's not 16.6. A lot of people get it wrong, but 0.5. Great. It's going to have, so after I go through this, you guys can see my screen? All good?
Yep.
So we get that guy. Then we move into what is going to be the tributary width. And you're like, what the heck is the tributary width? Well, simple. The tributary width is going to be the length of our span of our joist right here. Tributary width number one, going to be that guy. Tributary width number two is going to be that guy. It's how long it is the thing that we're supporting. And if we understand it, half of that load is going to go to the exterior wall and half of that load is going to go to the other exterior wall. And all of this right here is what our beam is going to be supporting. Does it make sense?
Yep.
Okay, so we're going to go back to that. So we have 9'6", 9.5 is going to be our tributary width number one, 9.5. And you're like, Darwin, why are you putting the full length? The software already knows that they're going to be supporting half of the 9.5, okay? And then that's number one. That's going to be on one side. And we're going to go and see what the other side is. I actually didn't measure it. I didn't measure it. And you're like, scrap. Actually, I can't swear. Snap. I don't know what that is. Well, we do, because if we know that 26.3 is the overall length of the entire wall, and we cut down 9'6" off of it, we know that that number ends up being, I have it here in my cheat sheet, 13.7. I'm gonna call it 13.5. Okay, 13.5, 13.5. Great. So we've already loaded this baby. He already knows how long it is. He already knows how much it's going to support on the left and how much it's going to support on the right. He already knows what the floor live load is and the floor dead load is, because that's a number given by the code book of what floors typically weight for any structure. All right, so we got through our phase one, loading this baby. Now we got to size this baby. And to do that, we go to our good friend right here, where we pick the material. There's all of these options of material: solid stone, glue lamp, steel, tooth steel. I go to our friend structural composites, and I immediately pick. There's a million types of structural, actually not a million, but this list. But we're gonna go to our LVL friends, or LVL friends. That's what we're gonna go to. And LVLs are divided into different grades: the 5E, the 8E, the 9E, the 2, all of those different grades. I'm gonna pick the strongest one out of all of them. I know you've already bought some LVLs. I don't know what the grade of them is, by the way. I have no idea what the grade of them is, because I can't see it on the document, but I can see what they were size-wise. And you had 11 7/8 LVLs. And I don't know how many of them you had, but I'm gonna put 3 of them, and they're gonna be 1 3/4 by 11 7/8. And if we go to our good friend right here at the bottom, let me do the sketch. So we pick this type of material, we pick the grade of the LVL, actually the grade here, we pick the amount of them, we pick the sizes of each, and the sizes of each, and then we go to our good friend, the equal button. Yeah, that's gonna tell us whether we're doing a good job or not. And the equal friend says, ta-da, we fail by 81.3%. We cannot do that. Now, didn't we know that? Because on our session, number 1 session, we said that these got to be that amount in inches for it to actually work. So let's see if that theory proved to be right. If we go with 16-inch LVL, 3 layers of it, what happens? Ta-da, we're good by 27.2%. So our theory works. So we would need a 16-inch deep, 3-layer, 2.1E, 3100 F LVL for that to work. Now we do have a problem. What's the problem? Well, I'm an architect. I have a good background in engineering. And the problem that we have is that we have our floor, we have our ceiling, which we sized. And it was about, what was it, Will? 7'6" or so?
Yeah.
Right?
7'6".
Yeah, and if we put that guy, that LVL, to be sitting right there and be 16 inches, which is 1 foot, what? 4 inches?
Yep.
We're gonna be having a problem with our ceiling height, right?
Yeah, it'll be 6'2".
And you cannot have a 6'2". So what are the solutions for that? Number 1, we can flush frame. Flush frame means we're gonna have our 3 LVLs, and I'm sketching it really big, right? And then we're gonna joist hang those babies. Whoop, that way. We're gonna joist hang those babies. Whoop, that way. We have another problem here, though. Do we really want to? Yeah, do we really want to see that? I mean, that's horrible, Darwin. You're an architect. You shouldn't be doing that. So what options do we have? So there are a couple options we have. I'm gonna pull up our sketch real quick. Option number 1, reduce the span. Put a column here and put a column here, and then this is going to be our new span. That's gonna start reducing our depth. That's option number 1, right? So that will make us that we probably could use, they call it 12-inch, but you guys know LVL is 11 7/8. You don't have a 12-inch. That may start helping us. Now, our joists, I have no idea what the depth of them is, but I highly doubt that they're 2x12s. Highly doubt it. Why? This building, Will, that was the first thing you told me. It was built in 19 blah, blah, blah. It already
1920.
Yeah, it sounded like they weren't 2x12 back then. They were nothing like that. So they're likely 2x8s or even 2x6. So even if you flush frame, you'll have a problem. Now, I'm not here to make the Taj Mahal. I'm here to make sure that you're profitable, Will. I'm here to make sure that this looks good and it works. If you see a little bit of an LVL, I don't think it's gonna break the budget. I don't think it's gonna kill people. I don't think people are gonna be upset about it.
Nope, we're
I-
good, my friend.
The
We're
only
good.
issue that we have is that how much of it are we gonna see and what's the code gonna tell us? Our hard line is our very good friend, 7-foot ceiling height. We do not want to have anything less than 7 foot because then it will not be an inhabitable space and then you cannot count on your square footage and we sell square footage. Chin chin, right? So we got to just maintain that. So I'm not giving you all the answers right now. I'm giving you a couple of options. So option number one, we reduce the span here, reduce the span here, and that may help us. I have no idea what that is, but I could probably get us a guess because this may be 3 feet. So we could probably take 3 feet off of the 16 feet because that stair has to be 3 feet to be able to comply with the code. So that's already telling me that. And that we can change those numbers right now. Actually, let's do it right now. Let's change. Actually, I don't want to change the numbers yet. So let's go to the option number 2. If we want to maintain the column in here, what do we need to do? Well, we can't use, and we want to maintain the ceiling height. We cannot use LVLs. We're going to have to use our good friend steel. Steel. Why? Because steel could be any depth and it will support that like nothing, Well, we can test it. We can test it. If I change the material, I know I don't want to test it right this second. So let's just change the span to instead of 16.5 to 13.5. And let's say that we're not going to do a 16-inch LVL. We're going to do 11/7/8 and let's see what happens. Boom. It passes. It does pass only by 0.7% though. That's like laughable, but I'm good. I'm good. You know what I mean? Like 9. Yeah, that will do it. I mean, it's 0.7. So just keep in mind a couple of things. If it says that it passes by 11.7%, is using these values for deflection on the floor size, and it means that it actually passes by more than that, but the code wants you to be friendly on that end. Okay, so that would actually work. That would actually not be a problem. So you could do 11/7/8, which is what you're buying. Just make sure that you're using a 2.1 E, because if you use any lower grade than that, your building is gonna fall. No, it's not gonna fall. It won't fall. It won't fall. But it will not pass the code, today's code. Okay.
Yeah.
It wouldn't fall.
Ray, does that make sense?
All right.
Yeah.
We're good. The other option is we still do the 16.5 span, but we go to our big baby steel. And now you would say, well, what about prices? Cost money. Comparably right now with the prices of wood, steel costs just about the same. So you could probably do a W12, W10 by 33, and you'll pass like 77%. And you're like, what the heck does W10 by 33 mean? I like to explain everything. That's the difference between a loser and somebody that doesn't know what they're doing and somebody that knows what they do. So W10 by 33 means that this is going to be 10 inches, a little less than 10 inches, because nothing comes out of the shop perfect, but 10 inches deep by, well, it's 33, by 33 pounds per linear foot. So you can know how much this is going to weigh just by looking at this. And how much is it going to weigh? Hold on. Chun, 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 chun. So we know that it's going to be 16.5 times 33 pounds per linear foot, 544 pounds. Okay.
Yeah, that's a heavy one.
It is a heavy one, and you cannot do it alone. Do not do this at home, right? You cannot do this alone.
Yeah.
You're gonna need some help. So, and actually, it's not that.
How does that
heavy.
look though, Darwin? Because these beams would be exposed, no?
No, you would probably barely see much of this beam. You would probably won't see much at all. Just a little bit of trim. You know, you wouldn't really see much. So I haven't drawn. I haven't. Okay. Yeah, because it's like it's gonna be this guy. You know, it's a T shape. We're probably going to.
And so we just need it.
Hold on. So we're gonna have this guy like that, right? We're probably gonna put some wood nailers inside it, and we're gonna joist hang off of it. It's gonna be just like a wood with some bolts through, and then the floor joists are gonna be just hanging off of that and off of that in both sides. You would really see very little. If these are 2x8s, You know, they're gonna be inside. If these are 2x10s, they could probably be nudged a little bit, just a little bit. You know, not like what you have in your basement. That doesn't look good. But this is how you're gonna do it, and it's gonna go all the way through. Still is a good way. It still is a good way. Now, wow, you know, I like to end with my honest financial opinion, like what I would do if this was my flip. Dude, just put a column here and put a column here and call it a day. Why? You still need the stair. If you wanted a full open concept, then the stair will have to go, but you're never gonna get a full open concept. So you just do a column there, and you'll be good. And do your LVL right here. Don't go all the way through. Now, I don't know what this lands down in your basement. I haven't drawn your basement. I don't know. It might kill the space in the basement. But knowing you now and knowing what you're trying to do with the basement, which is clean it and make it that they could do whatever they want with it, that's fine. Put a nice column right there, okay? I have not sized your LVL that goes in here, and I'm not concerned because this is only 11'2", and it's not supporting this joist because this a little addition goes like that. It's only supporting your gable end of this whole gable end, that little bit of your gable end. It's really not a whole lot of load. So I'm not concerned.
What about on the other side? Are you concerned on the other side?
About what? I'm not concerned about this LVL.
On the LVL. Nope. Go over to the right. In front of the stairs. Nope.
This we already spoke about, so nothing. What do you mean?
This one right here. The one that's 13.7.
Why would you need an LVL anywhere on the 13.7 side?
On the back half. I thought you said we needed some support there. You said it was holding up some of that wall between that dining room.
No.
Okay.
This is what you're talking about. This is your entrance. This is your malt room. This is what you're talking about. Okay. That's the one. You're a little confused. This is your master bedroom.
Then the stairs aren't on the right side though. The stairs are on the same side as the mudroom.
Yes.
Well, there is a stair. This is the front entrance. There's a stair right in front of it.
Correct.
Yeah, that's what I'm drawing. This is the entrance to your master, where you're gonna have a bathroom somewhere in here and a half bath somewhere in here for both of them. This is that space in question that we have. We have another stair right here that's going to your basement. Okay. And this is where you have your bay window. Does it make sense?
Yeah.
One thing. This is why I get paid the big bucks.
No, you're good, my friend. It's just when we were talking the stairs, I'm thinking about the other stairs. So I think I understand what you're saying now. Yeah, I don't think there's a problem with that recommendation.
All right. So right now I'm gonna put a quick report together of this, and I'm gonna send it over to you. And then I'm gonna write my full scope of work agreement for the whole set of drawings for the whole building, like whatever we need to do. And then we're good to go, guys. This is great. I don't need to record anymore. Subscribe to my channel. I hope I have proven myself to you.